Alright, so I've definitely mentioned this before, but I'm not sure I've mentioned it exactly this way. So the pi 3.1415926535, etc. It is effectively the 4 of circles, right? Because when you have a figure with a square and a circle circumscribed inside of it, or a circle inscribed within it, the square circumscribes the circle. The perimeter of the circle, the circumference, relative to the distance across the circle, is pi. And the perimeter of the square, relative to that same distance, is 4. So pi and 4 relate to each other in this way. Pi is the 4 of circles. This is why pi is 4 times too big to be the fundamental circle constant. But if you look at the area, we end up with that same relationship, right? You end up with pi to 4 correlating the areas, which indicates that it's the fundamental circle constant, because you get the same thing indicating the relationship between a linear property of these two shapes and the area of these two shapes. The classic way of finding the area of a circle, though, is using this. Pi r squared, the radius squared. If you do that, though, you end up with, what you're doing is you're taking 1/4 of the circle. Right? You're taking 1/4 of the circle, and then you have to, have to multiply that by 4, which is why you get pi instead of pi on 4. Because if you take pi on 4 and you multiply it by 4, you get pi. So the fact that we're taking 1/4 of it artificially and then having to undo that later is what gives us pi in the first place there. If we do this as a general approach to finding the areas of things, you end up with an infinite regress for squares. And this part I know I've mentioned before. This next part I might not have mentioned, I might have just alluded to it. But it's kind of the crux of the point here. So what you end up getting if you do this with squares, you get this analogous expression here for finding the area, right? You get 4 radius squared, where the radius is the distance from the center of the square to the edge, the shortest possible distance, right? Now, the problem is this here is also a square, so we need to find the area of that, right? So r squared is going to be something, some other radius, so I'm going to call that r prime just for convenience, and it helps if I know how to type. There you go. So r squared is, well, no, it's not that, it's this, 4r prime squared. But then you end up with, this is a square, so you end up having to do this. R double prime, or r prime, is 4 times r double prime squared. But then you have to figure out what r prime is, and yeah, that's a square right there. Going a little bit too fast, and I'm looking down at the keyboard while I'm typing because I'm an idiot. There we go. Now we've got something. There we go. So now you end up with 4 times r triple prime squared, right? This ends up being an infinite regress. Well, if we collapse this all back onto itself, we end up with an infinite product. And the infinite product is, whoops, like this. Why don't I just do this? It's this. You get this infinite product, but it's the area of a square, so this must be convergent. this right here must be convergent. How is that convergent? What does that converge to? This is why pi cannot possibly be the fundamental circle constant. Because if it were, you would end up with paradoxes like this.